All right, thanks everybody for joining today. Um, I know that a lot of you in the campus space are starting to get ready for the students to come back, so we thought it was a good time to revisit everybody's favorite topic, data performance. And Ken has been putting together a lot of good material for the data mobility challenge in the past couple of weeks, and this will serve as a bit of an update, but also a little bit of a call to arms for the campus environments to prepare a little bit and ways that ESnet can help with testing and evaluation and trying to iron out any of the problems that may exist. So with that, I will turn it over to Ken to talk a little bit about performant data mobility.
All right, thanks everyone. Can you see my screen here?
Yep, you're good.
All right, thanks. So looking at the start of the semester is always challenging, and a lot of times during breaks like that, there's a lot of campus upgrades and a lot of things getting ready for the next semester, and summer's a big time to do that. Especially after everyone kind of relaxes a little bit after May, into June a little bit, then July after the July 4th holiday, it's like everything ramps up for the fall semester. So and just with data constantly growing and network utilization growing even more and more, especially over the last few years, these are just some of the different things we learned, have picked up through EPOC, related to, and as well as ESnet through some of the testing and some of the support calls we've had, some of the just different things out there that we've kind of learned and picked up along the way. So just kind of getting it out there. We really don't have a checklist or anything major. It's just a matter of, a lot of best practices or trends we've seen, including, just different things to go out there to see what, campuses need to get ready for the fall semester. So one thing we're just start off with the baseline, what we're looking to go after here. So this is really the last slide at the beginning, just to kind of level set what we'd like to be able to see across the campus network, from the Science DMZ, or if something is behind a enterprise firewall or something like that. We'd like to see a minimum of this 2.2 gigabits per second data rate across the network for data transfers. But when you talk to different groups, the different audiences, the same number is translated multiple ways. So for a sysad or storage admin, you're going to see it in megabytes per second versus gigabits per second to a network engineer. And then to a researcher, they really talk about the total data volume, and they do it really in rates of hours. So how many terabytes per hour are we looking at here? So this is where we like the baseline as we engage different groups through the DME and through EPOC. And we're looking at some of these sites also for looking at for ESnet, the different facilities and things like that. We know these numbers are low, but the thing is, a lot of sites are not even getting these numbers. There are much more performance systems and things like that, but we're trying to set this minimum baseline to try to, that expression I'll use a little later is raise all boats. And so with that, what we want to be able to do is just make sure people are, paying attention to the data transfer performance. And this is just a simple scorecard to kind of see where you're at, no matter which of the three audiences or which rate you're looking at when you speak about this. We tie this back to petascale project, and some of the other numbers over here to transfer a petabyte per week, but at the campus level on the 10 gig capable DTN or multiple 10 gigs or even 100 gig, some sites are still not getting some of these numbers. So to be able to transfer a terabyte an hour, 3 terabytes an hour, something like that on a capable server, petascale is really only double that, 6 terabytes an hour. So looking at these numbers, really, the petascale world isn't too far away for most modern systems. But like I said, we're starting this out with the scorecard this last year just to kind of see where everyone is. And like I said, this also breaks it down per audience. So just kind of the what we're trying to get to starting off. So when you look at campus networks, what they add value for the enterprise, I mean, they're really essential for everything anymore. Before it used to be years ago, it's like, oh, just for, the student services or things like that. Now everything is connected to the network, including building automation, registration systems, financial systems, the Wi-Fi networks, the res halls, and including, every campus, even campus podiums and teaching environments, academic environments, but also for the researchers. So a lot of these are really driven around campus traffic utilization, or what we call mouse flows, where it's just a lot of traffic, a lot of clicks of traffic, things like that out to websites, and just transfers here and there. Video with Zoom and everything recently has really bumped that up a little bit over the last 2 years, but a lot of times these networks are really designed around campus traffic utilization. and also connectivity out to the users. So that's another piece that we look at, is how the enterprise networks are designed. Performance is based on utilization, and obviously, or a lot of times, uptime, availability of the network, not so much the performance of the actual network. So that is a indicator of the operational state, not necessarily the actual performance utilizing the network. The awareness of the problems or connectivity, whether they have access or not, really not about performance. Like, it's, oh, I can't get to this. It's usually not, it's slow, it's either up or down, because the network's almost like a utility at some stance, and an enterprise network, it either works or it doesn't. There can be some performance issues, but typically it's just the availability is the biggest key factor for a lot of enterprise pieces, and then based on the utilization. The troubleshooting is usually a ticket. It's usually a one-off or one-to-one type piece with a network engineer, sysadmin, or a help desk administrator. It's typically campus networks, even if you having drop packets, dirty fiber, flaky patch cables, etc. As long as the connectivity is still there for some of these things, then the normal user is really not going to notice much of a difference. Or that comes down to a previous colleague of mine called it the human TCP factor. Whenever they'll just click and then wait a few seconds and click again, and then click and then click, and just kind of like, just why isn't that working? And then they click again. This human TCP factor, he called it, was something you just kind of work with. And eventually, if the connectivity just it stops for a minute and it comes back up, then here we are. So as we turn this pretty much flip the table on this and look at the change when you value campus network for science, it's really engineered towards elephant flows, which are the large flows, a single user, big flat rate transfer going through a network. And some of this can be the same. One user can transfer the same amount as the entire wireless network. We've seen that different times. A single user on a single DTN on a major science transfer can take as much as multiple thousands of people connected to campus Wi-Fi, just generating traffic. So you might have 5 or 6 gigs of traffic running, on a data transfer, and you might have 3 to 4 gigs of traffic running on Wi-Fi with multiple thousands of users on it. So, the capacities are the same when you look at the utilization, a lot of traffic overall, but the scale of it, one user compared to multiple thousands is, what we're looking at here for the difference for science. Performance is measured not as utilization and capacity. I messed that slide up, sorry. So what we're trying to say is the performance really is based on not necessarily the uptime and the utilization and the availability, but it's really based on the throughput you're getting through there, the amount or the quality of the throughput you're getting through there. So it's a little bit different when you look at that, and we'll explain here a little bit more in a minute. The troubleshooting often involves a handful of people at networks. A lot of times science is a collaborative effort around multiple sites, multiple institutions, pieces like this. Large buffering equipment is required for WAN transfers to make sure they're performant. Typically in an enterprise network, this is not even something to look at for requirement. Drop packets across the larger campus networks, like sprawling across the state, or even a wide array transfer, very, very bad. And then you'll notice when you have flaky equipment or dirty fiber, patch cables, etc., because the amount of time and the amount of loss on the network or the retransmits really can affect data transfer performance from there. So as you get into this, a lot of times campus networks, enterprise networks are set up for speeds and feeds is a common requirement. Really how many ports do we need? What kind of port density does a router have? And you're getting out to some of these locations in that realm. So the other piece around it is, I mentioned this just a little bit ago, that typically it's measured around utilization and capacity, but you should also include loss in data transfer speeds for particular services on an enterprise network that could be valuable to this. So a lot of the things we learned from building and engineering networks around science traffic flows can also be applied to individual services on an enterprise network as well. Especially for like authentication and things that are taking time for transfers or database access to a remote database, across the campus network through the data center firewall to the data center. These kind of things can also come into play. So there are things that can kind of overlap with some of this, but for the most part, when we would engineer it, it's typically utilization or performance. So from there, the other piece around it is it's difficult because you get a variety of equipment when you're looking at both science traffic and campus traffic or enterprise traffic, Wi-Fi, and you have to do with a variety of equipment. So you have to have multiple sets of requirements depending on the service you're trying to offer from the networking standpoint. And then here's a comment I made a little bit ago where one researcher's data transfer could equate to the same amount as multiple thousands of people on a Wi-Fi or a dorm network, things like that. So as we get into this, here's a graphic I pulled from an old talk. Yeah, Eli and Jason around here. So, anyway, water going through a pipe, if you're dropping out 1 out of every 20,000 water particles out of this volume, still gets roughly 99.9% of the water through there. But on a network pipe, the data still gets transferred, but the transfer is roughly 5% of what it could be. So you really have a major issue whenever your network is not tuned properly, or you have issues on the network, things like that. So if you're just trying to get water particulates through there, you can get it done, but the problem is when you're trying to get a certain amount of water through there, the time is really what comes into it. So by engineering your network for both, or engineering a network for science traffic first, then a lot of times the mouse flows will just work as well. So as we get into campus readiness for this, what happens we have a lot of different things we've done over EPOC over the last few years that we'll kind of pull out here, but just as kind of refresher what we're doing for the perimeter of your network. Some people are calling it border, perimeter, edge, but some people call the edge all the way down to the access layer where the user is. So there's different people use different things, but here we're going to call the perimeter like your first connection to the world or your border routers. So the thing we run into the most is we have MTU mismatches, and that's the biggest thing we run into a lot. We actually have a paper on MTUs and things like that, but that can really affect data transfer performance. MTU mismatches, subject to network connectivity, you might have just services not operating efficiently. That's one of the things we run into. So if you're going to figure out your MTU policy for your campus network, whether I only have jumbo frames on for your science traffic. If you run MTU everywhere as default, and then you make the access layer just a normal 1500, whatever your MTU is, make sure you're paying attention to that when you're looking at some of these configurations. The second thing is adjust your BGP to prefer the RNE networks. That's one thing we'll see different times is we'll have asymmetric routing where it'll maybe go out over RNE, but it'll come in over commodity. So there's a link here in a little bit about the routing working group to be able to assist with some of the BGP policies and things like that. So you are preferring ESnet or internet 2 first, or your regional network first, and then you prefer your commodity network second, or you have a BGP policy that's reviewed, I would say at least a semester basis. I would probably say quarterly. That way, if you get it halfway through the semester, you're at least prepared for what you're going to do during the next break. And then the next break, you check it again. BGP policies are becoming a big deal because there's so much information is connected to the network, or so many resources providing information are connected to the network. And then as you get services split across local versus on-prem, or in your data center or remote data center, or even in the cloud, these kind of issues can really come into play. So you really need to understand where your traffic's going to and from. Another step is to make sure you have a perfSONAR server at each of your border routers. That alone will really kind of divide and conquer the problem. Is it us or them type thing? So, and with that, yeah, you can actually have that set up on there to be able to, adjust and find loss, latency, jitter on the network. You can find your routing paths. You can find your routing preferences. You can determine all that just by putting a simple, less than $1,000 server at your border router connected to 10 gig. And that's more than enough for most of these transfers. And like I said, it doesn't have to break the bank. I mean, what you spend for an optic on one thing might be able to pay for, an individual server there as well. So here's the link about the net stage and the routing working group talk. There's a link there. But like I said, you can look on different pieces on how to view your traffic. We're going to go into that a little bit here in a little bit, but the routing working group is also a great resource to be able to look at this. And also, as you're looking at this, look at the manners guidelines related to your perimeter, your network, how you're advertising, your routing security out to the world. And the last thing you want to do is get hijacked or something like that, and your routes go all over the place, or someone misappropriates a BGP session somewhere else and takes part of your network. And so it's better to take a look at the manners policy and get that in front of your security group and make sure you're reviewing that as well for your perimeter pieces. Something else at the perimeter is sometimes you have what looks like a major transfer coming in or a lot of traffic all of a sudden, and you're not really sure what it is. Some people, right away think, oh, it's a DDoS attack, but really, another colleague of mine called it the power flush. So if you're like a a hotel everyone somewhere, and everyone just flushes the toilet all at the same time, what really happens to that? So the same kind of thing happens here when mobile devices or iOS updates happen. Everyone upgrades at the same time. You can see this mass influx of traffic, that you're like, what is this going on? But then when you look at it, it's really just an iOS update, or we've res halls, you might have a new game that came out, and everyone's hammering on Blizzard or something else like that, downloading the latest thing. And other times you might have streaming events happening on campus, that really can affect some of the traffic as well. And all of a sudden, you're like, why is my graph up, 30% today? So situational awareness and things like that can also look at, what's going on to prepare for these kind of things. So make sure you have a capacity planning model built in place, that you have enough headroom. Typically 40 to 60% is a decent operating range. And then once you get above that, 60 to 80 is like where you start really needing, leave that little bit of a headroom up there for these kind of events that happen. And then, take a look at that. So as you look at some of these connections here, there's multiple ways to set up your perimeters. Just looking at this really quickly, you have, if you're an institution that peers directly with ESnet, Internet 2, the peering exchange, I think there's a Cloud Connect service now, or you connect directly with your regional network, then you have commodity connections. So you can have multiple peering arrangements here you need to be able to set up. A little bit more direct is if you connect directly to your regional and then they do all the peering to the other big sites. That's another option here. So this graphic's not accurate. It's just trying to represent the multiple ways you can probably set up your perimeter to take a look at the outside world. And then as you get into this, this BGP policy here might be quite a bit easier. But like I said, you need to make sure that once you land on your regional, you're verifying your regional traffic that you're going out the appropriate path too. So it's not just your network you need to pay attention to. You might need to have a call to someone else too. I'm not saying, regionals are bad or anything. They're actually quite good. But it's just the fact that, depending on which connectivity you have at your campus level, again, readjusting and looking at that BGP policy really can help drive performance on the network, as well as, other services you need to connect to on the outside. And then once you start stepping down into this, this network diagram really has a Science DMZ over on the left here with a Science DMZ DTN. You can kind of look at the connectivity there. But also if you're driving everything through your firewalls, you might have multiple levels of policies here into multiple segments on your campus network, or they may be segmented a different way or not at all. It may just be one big firewall policy. But anyway, you might have different links into here, depending on what you're connecting to and things like that. So it looks like Epic is part of your enterprise network, which it can be if you give us a call. So anyway, so the campus DTN is another thing. Some sites, there was just an email thread about that recently about, do people set up campus DTNs to be able to handle traffic from instruments on campus? And yes, some sites are doing that, and they'll go up either land, hopefully on the core router, and then back to the data center. Sometimes they may go up to the firewalls and then run through the data center firewall policy and go back down to the data center or where the HPC cluster is or whatever. So these DTNs and data transfer performance don't just affect the WAN performance and things like that. They can also be, affecting or going across campus. So you need to pay attention to your campus networking as well if you are generating data or you're transferring data locally across your campus. So this is just a very high level network diagram, pretty busy, but it's kind of just representing the multiple ways you can kind of connect to the outside world, as well as across your campus network. So on the data architecture side, what we just looked at, please verify your MTUs. Again, we have so many tickets related to MTUs. I think, we're gonna get stickers at some point. So the second thing is, kind of research your Science DMZ and try to see what things are out there. And some people think it's outside, it's just the Wild West. It's like, oh, there's no firewall, and there's actually, ACLs locked in place. There's some people put clients directly on their DTNs. There's different ways to set up your Science DMZ to be, quite a bit secure, for those reasons. And the idea of the Modern Research Data Portal is the link there that'll separate that out. And what that does, it separates the authentication, authorization, and the web pages and things like that for the actual data you want to get to. And then when you do a transfer, it runs an API call back to the data transfer node directly. So in the previous example, you may have down in the data center a virtual machine running the Modern Research Data Portal here, that all the authentication comes down to your firewall. You're checking, SYN and flood attacks and things like that to the website, all these other security things you want to look at. But then when you actually click to do the transfer, it may open up and do a transfer from the Science DMZ DTN on the outside here. then you may just be able to transfer quite a bit more efficiently that way. So it's just an option to look at. So the second thing is try to set up a weekly meeting for your top 10 source and top 10 destination reports, just to kind of keep an eye on transfers or what's happening. Just schedule a meeting with yourself, I don't know, Friday afternoons or something, maybe not during the 2 o'clock after lunch siesta, but the things that are out there that you can take a look at, some of these just simple reports like that, just keeping an eye on a trend on your top 10 source and destinations or top 10 source and destination ASs. That's another one you can take a look at. You'll be able to see pretty much where your traffic's going to and from. It's pretty interesting when you start looking at these pieces. And if you don't have these kind of tools on your campus, you can check out NetSage. And if your regional is participating in NetSage, you should have traffic directly about your campus related to that, since it's going through a regional. Another piece on the data architectures, everyone thinks you need to match up, your 100 gig DTNs to your 100 gig ports to your 100 gig backhaul and your 100 gig. It doesn't really, 10 gig DTNs will really go a long way, or a cluster of 10 gig DTNs will go, work quite well when you're doing these data transfers. From the scorecard you saw at the beginning, we're really at 2.2 gigs a second on a 10 gig DTN is our minimum baseline. When you get to half a petabyte, you're at 6.6. So that's still, you're still transferring 3 terabytes per hour at that rate on a 10 gig DTN that you can pick up for pretty reasonable. So when you get to 100 gig DTN, all the extra pieces, all the extra expense in there for the optics and different things like that, you can set up and get a cluster of 10 gig DTNs for some of these other features like that. So, and if you transfers must go through the border firewall or restricted control path, a lot of firewall vendors have what's called a fast path, express path, fast and ASIC path through your firewall. So once the flow has been validated, it can bypass the rest of the analysis of the flow going through there. So there might be things like that too. If you have, some sort of funding requirement, you must have a data transfer through a firewall. You can look into your firewall vendor and make sure you're at least getting 2.2 gigs a second through it for performance, but also look at the ASIC path. And their different firewalls have different marketing terms on all those pieces. So from there. And then at the bottom for DTN tuning, we did a talk on this. I think George and I did a talk on this last November. So you can go out and find that on Epic there. I can put a link in the end of the slides when I post them if you need, but otherwise just get a hold of us and we can share that. But DTN tuning, you can do quite a bit just with turning a few knobs on the DTN, and you can get quite a bit of performance out of that too. So, but yeah, really check out the clustering of 10 gig DTNs. You'll be surprised really what they can do, and you'll save quite a bit of money and effort around that. So. Here's just a link, some NetSage links. We'll get into this a little bit later. The data mobility exhibition is linked directly there that shows you the data transfers to and from the data transfer nodes. If you want to see your NetSage traffic by institution, this is that top 10 flow report we're looking at. That second link there, if your data is going through a regional somewhere, we probably have some of your data going through there, at least across the RNE. So you might see that there directly. And then if you want to register your DTNs within the science registry or your data architecture components, you can actually register that in the science registry there. And then as you engage Epic related to any sort of data transfers down the road, or if you are requesting some sort of science review on your architecture or something like that, we can help. And these are just a few links related to that, looking at flow analysis and flow tools. So part of the routine testing, how often do you review your transfers to researchers? If you do that top 10 report like we're talking about, and then you scale up from there, one thing you can look at is try to schedule, a semester every two months, maybe something with a researcher, maybe a part of your top 10. If you see an instrument or you see a data set or a lab or facility you're transferring to on your campus, maybe you want to go down and meet with them and try to see what you can do to help them out and go from there. At the same time, your transfers to your network traffic, there could be other things related to that, that you'll see randomly on there. So I have in that top 10 report, you can see quite a bit of traffic through your enterprise network as well as to your science DMZ or just anywhere a researcher might be, because maybe you can see what their traffic's doing, and then you can actually, be able to adjust and be able to assist them in different ways. One thing on the perfSONAR side, perfSONAR can do persistent testing. So you can set that up. We talked earlier about setting up a perfSONAR server at your perimeter and plug that directly into your border routers and be able to have that The other piece is if you have a perfSONAR server and you're working with someone to put a new instrument in, try to put a small perfSONAR at the instrument edge, especially if you're generating a lot of data. That can go a long way. Even a little 2-post rack, half depth, that weighs like 8 pounds. You can put this thing on there. They're less than probably $1,200 for a 10 gig connection. That a little perfSONAR server alone, right next to a cryo EM or some kind of scope instrument, will really benefit a lot. The other option too is mobile testers. If you're having an issue, have a stack of old laptops, there that have a 1 gig port in them. I've used those so many times in the past, and they're just easy to have available. You have them plugged in the network, you load perfSONAR on them, it pulls all the data down, DHCP or static IP, whatever you need to do to get that running, and then just carry it down and drop it off in the lab. That's another way to get something at the instrument edge very quickly, and really at no cost. It's really, go out to your salvage or whatever, hit your university and pick those up. Another few options we're testing at ESnet are the E300. We're deploying those on an internal network at ESnet. Then there's also a Supermicro shallow depth server. I've used a handful of these in the past. There's a link there to those. They're the ones I'm talking about that are anywhere. Well, they were anywhere from $800 to $1,200 for a 10 gig node for that. So, and Dell also has ruggedized servers you can carry around as well. That's kind of the same thing. They're, not too bad to do work with. Don't forget about the Docker container. A lot of people forget that the perfSONAR now is a Docker container that you can go out and plug in and be able to do transfers really anywhere you're at, running your host networking off your laptop or whatever you want. So that's another way if you need to load something on there, especially as researchers are looking at containerizing things like this. You might just want to, explain to them about the perfSONAR Docker container to be able to drop within their data architecture, whether it's microservices, whether it's somewhere in the cloud, whether it's different places. It's a very turnkey way to get performance testing set up very, very quickly. So, and then a few examples of data mobility testing going forward are really the petascale DTN that happened a few years ago with the ESnet, and then also just last fall the LEC data challenge. These are both efforts that were made to be able to verify, kind of stress test through a live environment, really what transfers were happening, or the data challenge was, running a set of data, and be able to see kind of how things were handled from there. So building a model around that with one of your, say your top 10 researchers, what data transfer researchers, that's another way to look at this. So the petascale model, we're going to go into in a little bit second here. Yeah, I'll explain that in a minute. Anyway, use NetStage, another tool to look at this. Add DTNs to your science registry. These are very quick ways. We plugged this a little bit ago, but again, just reiterate that. When a network is engineered for elephant flows and WAN transfers, campus transfers can typically do 4 times faster or more. We're seeing that quite a bit. It just depends where you're at, what you're doing, how deep the campus network is, where the instrument is. But if your campus is also fiber rich, we've recommended this to a few sites. Instead of just passing them through, if you have fiber going out all the way to the instrument edge, just try to get campus fiber patched all the way through that and backhaul or bypass your existing campus core if need be, because if access layer switches are holding you back or different things like that, you can actually drop something off all the way to the instrument edge just using campus fiber sometimes, and that will just save you a ton of work, and backhaul that to your data center network or somewhere else you can get your data transfers to and from. The value add package, this is kind of interesting. Rayon's page has a piece on this, what you're doing to your network, how your network adds value to your commodity. Having these pieces you can plug into your CI engineering plan, or having a facility, information sheet like this, really can show what the network is really, because people just assume the network works, but everyone has had the spinny wheel or whatever you want, or they've waited for things to load or buffering or things like that. But when a researcher does their transfers and things normally take an hour, but now they're taking, a day and a half, there's a major issue there. So the value add page in Rayon's page is pretty interesting when you look at that. So again, I'm going to repeat it again. Check your MTUs. We run this all the time. The 100 gig perfSONAR, 100 gig DTNs that are out there. Yeah, capacity doesn't always equal performance. So like I said, these 2 papers we have out there are related to that. And like I said, any issues or any questions you have on this, contact Epic. And this is just another plug in the middle here. So So getting into the petascale piece, really this is just, looking at where things were, how transfers were happening, and verifying what was going on here between the major supercomputing centers across the DOE and also NCSA. So you look at some of these transfers, you're looking at this. As you go into this, you'll see, beforehand, this was 5.4 and they did some changes. They got up to 17 pretty quickly. They did some other tuning, and then you got the ALC up to NERSC, bumped up from 5 and 5.4 and 6 up to 15.6 and 21.9. So once you have some of these designed, get a baseline, run them through some tests, do a little bit of tuning, and you'll be amazed sometimes the performance you're getting on some of these pieces. And then as you step through this, you kind of see what the final numbers were on this. So you got them from single digits up to like 40, 42, 43, where that originally was like 6. So again, paying attention to this kind of stuff and going through an exercise like this and running, like I said, the data challenges or running these tests with your researchers here and there, especially to their collaborators. A previous issue I ran into was a research transfer was getting better performance off campus 3 states away than they were across campus 2 buildings away. So that just kind of blew my mind a little bit, but the researcher's telling me this, so we have to show up and try to validate everything. Not that we don't believe them, but it just seems kind of crazy. So, but yeah, when you get down there and you understand kind of what's going on, and they're running data transfers using Globus to a different university a couple states away, and it's faster than going across campus, then you start looking at your local network and see what you could do there. So that's where the perfSONAR at the perimeter can really help. Is it us or them type thing. So yeah, some of the improvements for here are just listed here, what they were able to tune out from the petascale challenge. But like I said, doing these stress tests, data challenges, data mobility tests, routine testing like this, they'll really start to illustrate where you need effort and where you have overspent or where you're under delivering. There's different ways to phrase that. So the petascale piece, a couple slides from Eli's piece here, the efforts from petascale, like we said, lift all boats, so this really benefits what's happening out there. They talked about the science portal and different pieces like that. There's a link there to that if you want to look more into that. So kind of this testing architecture that was available. But one thing you think about takeaway is how would persistent testing benefit your campus? If you met with a researcher, once every 2 months, once a quarter, twice a semester, I don't know. Things like that can really go a long way to both understanding your network and your traffic as well as your data architectures, but also benefit the researcher. They may have other things they're looking at too. So aside in getting through all that, the idea is really to scale out the petascale idea, and that's what the data mobility exhibition is all about. So really take the idea of understanding, where your network's at, what kind of data architectures you have, and going through those different pieces related to data transfers and workflows, whether they're on-prem, off-prem, collaborative, cloud, whatever. Drawing these out a little bit and understanding what's going on. People really don't understand sometimes what their expectations should be. They just know how long it takes, or they just click it and they let it run all night, and hopefully it's finished by the time they get back. Different things like that. But networks are essential to this, and campus networks are extremely critical because that's a lot of time the one edge of what's going on. And the problem we're running into is a lot of the campus networks now are designed really around enterprise speeds and feeds and utilization and availability and uptime and redundancy, resiliency, but true performance is often overlooked for these cases. And so with that, we got to keep reiterating that you have to do both. If you're a large institution with a decent amount of research revenue, I mean, if you take your annual budget and say, it's, a number, and say it's 20%, say your research budget is 20% of your overall campus budget. I mean, for the entire university, entire campus, whatever. Are you spending 20% of your time on research? And that's something you have to start looking at is, are you spending the amount of time, the Jerry Maguire, show me the money type thing. It's if you're putting the same amount of effort in that the amount of spending is going on for some of these pieces, are you matching that on the enterprise and the science side of your network? So that's just something else to keep in mind, that we'll talk about all these router and switch upgrades, everything else, but if the performance is in there and often overlooked, then it can really be a detriment to what's really going on. So The easiest thing is to try to benchmark 1 terabyte of data right now. There's multiple ways to do it. We have a few examples here in a little bit, depending on the size of your campus and things like that. But that scorecard we showed at the beginning and we'll show at the end is really about the same kind of thing. So example of this DME testing framework, we have a series of sites around the country that really set up these data transfer sets. One is in New York, one is in Colorado, one is in Chicago. We have one in Washington now, and the one in Chicago on ESnet is now available. So we just got that tuned literally on last Thursday, I think. So there's also a new set of Argonne has a new DTN pull at the national lab up there. So they have a new data transfer set that can pull from a different file system on the back end. There's also 2 cloud connecting sites related to the DME to be able to do your campus testing out to Google and Box. And then Globus also has different connectors out to different various things. So you can kind of take the same idea and see what kind of data sets you get as well across your own Globus connector to cloud file resources. So what we're looking at here is really the amount of time it takes to transfer 1 terabyte. So if you're looking at 1 hour, this is at 2.2 gigabits. If you talked about it a little bit earlier, if you look at if you get up to the half a tera or half petascale is 6.6 gigabits per second, around 20 minutes to transfer a terabyte. So you can kind of see what the numbers look like there for that kind of piece. But like I said, we're trying to benchmark everyone here with file validation and checksums, things like that. We know it's a little slower, but like I said, we want to baseline everyone at that to start and then kind of move up from there. So again, just kind of repeating some of this, 10 gig DTN should be capable of transferring 1 terabyte per hour, really 3 terabytes per hour, but 1 terabyte per hour is our minimum baseline at 2.2 gig a second or 277 megabytes per second. On a campus, a 1 gig connected desktop or whatever should be able to transfer roughly a terabyte in around 3 hours on a 1 gig connection, or 800 megabytes per second, or 800 megabits per second, 100 megabytes per second. So even on 1 gig connected across your campus, you can not only do WAN transfers one way, you can also look at what your campuses are getting through different storage subsystems as well. And looking at that, an engagement piece you can do as well is try to go to college or department staff meetings and just bring it up and say, what are you getting for your transfers? Trying to understand what's going on. That goes a long way to, I guess, kind of showing you care, but also if you're paying attention to what's going on, and that you might be able to help them speed up their transfers across campus. We've had stories of people carrying hard drives across campus or jump drives, riding the campus shuttles between different places, because they're just, otherwise they're not complaining about it. They're just trying to make science happen. And when they do that, they take it on themselves and they just go out and fill their backpack or whatever full of drives and walk or ride or wherever to get to the Z location. And with that, it can be quite challenging and quite frustrating, but they're spending a lot of, research time and, sometimes funding dollars, taxpayer dollars, sometimes walking hard drives across campus. And it's obnoxious. So we need to, like I said, try to reach out to these folks and pay for it, or and help pay attention and understand what's going on. So same kind of piece here, that we're back to the DME. The way it works is you get your DTN set up, you transfer and upload, download different data sets as you need to. You measure against the 1 terabyte per hour transfer rate or some sort of specific requirement you're trying to reach. And then you can reach out to, us at Epic, that we can actually help you out at this point. So a little earlier, over 10,000 tests were completed over 2 years. We have some other updates here in a little bit for some more tests that were happening. So people are using it, people are testing their data transfers, and we have had some decent improvements once we started engaging them to do some tuning and whatnot. So, but yeah, so it's like I said, this persistent testing can really help and go a long way. So. Again, we drew the petascale line here in the orange yellow color, and then we did the 1 terabyte per hour range here. This is just a snapshot of the testing that's happened out there related to this. And you see the top 3 nodes are the nodes that are tuned well and how well they perform against each other versus, some of the other campus networks that are above the line, below the line, things like that. But this is we haven't updated this slide for probably since the beginning of the year, so we might have some different numbers when we look at this, but we'll get through that. So On the other side of it, the same kind of thing here. This is for downloads, for different speeds like that. So the previous slide was for uploads. I'm not sure why it's rolling off the right, but yeah, same kind of number. We're, drew the line across there just to kind of see where we were with some of these results. And again, here's the scorecard again. We're trying, like I said, the 2.2 gigabits per second is what we're looking at here. And then the terabyte per hour and the 277 is the minimum baseline. We'd like to see this. So tying back a little bit to the engagement of your researchers in campus preparedness, EPOC has a roadside assistance process. The issue is that this worked last week. Why does it now? We've had a lot of things like that. Think of that like a flat tire or, crash repair type thing. You're going to call to get assistance. It's really over, something you can't fix yourself typically. So just give us a call. We'll get something triaged and get set up with you at EPOC for this kind of thing. Another piece is if you kind of relate this to if you were driving your vehicle down the road and you were, at some of these other speeds here, you would probably pull off and get assistance or get a tow, right? It's the same kind of thing here. If your DTN is transferring at these slower speeds, you can give us a call and we'll triage a ticket for you and try to do some troubleshooting for you to try to help get your DTN or your science tuned up related to these pieces. So this is, assistance that we can do to a campus to try to help understand what's going on, because campus networks are they're challenging, their enterprise, their science, their Wi-Fi, there's secure segments, there's credit card transactions. They're very, very complex, and they're not just science. So there's quite a bit going on there with campus networks. So this is something we can do to try to benefit you on the science side and getting these things tuned up here. So one of the other pieces we're looking at, we talked about the 1 terabyte per hour. We have known endpoints here. We have 5 RNA regionals and 2 in the cloud right now. A standard globe is set up. We'll set up and work with you. We'll also work to find your bottlenecks to see what's going on out there related to some of these pieces, to get your campus ready. And even after the beginning of semester, if you notice something's going on, you can contact us as well. The data sets as part of the DME related here, the 1 terabyte data sets, 8, 10, and 16. We use those a lot. Another one is the 100 gig. If you have a smaller DTN, you want to do the 100 gig option. There's DS6, DS12. ESnet also has, I think it's on this slide here. It's coming up. A number of climate data sets that are 250 gigs each. So that all together is roughly a terabyte. So we can actually help you test really depending on the size of your data architecture or the DTNs you have. We have data sets to test across that accordingly. So this is just an example of what ESnet was using for their the DTNs last year. We have another set that we just finally received. We've been waiting for a year for these to come in. So we have some new DTNs we're going to be putting out for the public to test soon. We just got the demo or the development box stood up this week. And we'll have another one in Sunnyvale, then Denver and Houston after that, and then one over in CERN. So those are in the works right now. So here's that piece I was talking about before. Depending on the size of your DTN, ESnet, if you click this link, will take you out to the 245 gig data sets. And they're really the same size. They're just all broken up differently. So it'll kind of test both your network as well as your disk subsystem. So if you download those and then re-upload those, we can work with you on that as well. Then here for the larger system or the 1 terabyte data sets, these 3 here. And like I said, for even a smaller node or even, we have the 100 gig data sets if you want to try those out as well. So at that point, this is kind of the slide we could kind of go away with. Really just reach out to EPOC if you have any questions. Pieces there related to the end-to-end performance issues. The website's there as well. And then links to the DME program are here, DME testing. If you're looking to do some automated testing, Globus and Voss have handed out these DME utility pieces. They can do some testing on that as well and be able to understand, you can do some automated testing at that point if you really want to kind of see what this happens over time, or especially if you're changing something, you can kind of see as it's trending and graph the data, you kind of go from there. So I think that's all I had. If you have any questions, feel free. I think I see one in chat, but so.
All right, well, thanks for going through all that, Ken. Really good information. And what was entered into chat so far was Han shared a link to the information about MTUs and how everybody does it wrong and how we can help you fix it.
Yeah, mismatch.
And Brenna also noted that if anybody is interested in the routing working group, you can reach out to her directly at
Hmm.
meadb@iu.edu. So we'll put out a call for questions here. If anybody does have anything that they wanna ask Ken, I have a couple that can get us started. Um, in the past couple of months, I know that you've been working with a couple of sites on trying to improve and do things, because I can see the tickets, but not everybody else can. So, what are some of the ways that we've been trying to help out sites? You don't have to name them by name, but what are some of the common problems that we're seeing, and what are some of the mitigations we've been trying to do?
Again, the MTUs are one thing there. So another one would be a lot of times you can get a very cheap, inexpensive 100 gig switch that's fantastic and has all these ports on it, but really it's a data center based switch. And with that, the data center based switches are really what's called cut through switching, or they have shared buffer or virtual buffering or buffering in queue. There's a whole series of things on marketing slides on that, but a lot of times those don't handle wide array transfers very well. So adjusting MTUs, making sure your switch is not a shallow buffer or a cut through switch. We run into those a lot. And also back to the 100 gig pieces, people think they need 100 gig and they buy 100 gig DTN and DTN and they spend a lot of money and then it's just not tuned properly. Just because you're getting connectivity and the blinky light just doesn't mean you're doesn't perform very well. So it takes an effort just to get IT stood up, and then there's a second effort that goes into the performance side of things. And a lot of times, your staff's pretty tight and things like that, performance is overlooked. But setting up some automated testing can really go a long way, both on the perfSONAR side and this automated DME testing. A script that'll run once a week just to kind of give you a quick report, and you don't have to do the work. It's automated. You just kick it off or even schedule it. Those kind of things can go a long way on the automation side, especially if you're tight on staff as you're looking at this stuff. So but yeah, MTUs by far, but so
Okay. So we did have two questions that came in. Michael wants to know, have you come across any situations where drive speed impacted bandwidth performance?
yes, we're actually testing that right now on our current DTNs. That link I had a little earlier on our last year's DTNs, we're stress testing those right now. We're looking at RAID 10, and we're looking at XFS, we're looking at ZFS, things like that, so we can make sure that our DTNs are tuned properly. We have I think it was called El Bencho. We can put a link in the slide if someone can look that up. It was one that we're running stress tests right now on read and write on our disks. And then just one we had earlier, the one node, I think it was the Washington node, was the disk IO was around 50 gigabytes bits per second. The star node was 50, and the Washington node was 70 gigabits per second on the piece there. And then we redid some tuning on it. We tried it on a different system, and we have one node transferring 120 gigabits per second, and we have the other side of it transferring at 450 gigabits per second. But that's just on the disk IO on the back end, so we're not testing the network or anything else. So yes, if you look at the DTN tuning piece on the slides we have, or the previous talk George and I gave, it goes into some of these pieces where it's not the DTN tuning and data architecture tuning is not just a persona on the network. It includes the network subsystem, the disk IO, the disk performance, the file system. I mean, lots of knobs you can start turning. So it's just looking at some of those pieces and starting with the baseline, and then making one change, try another baseline, and go from there. So yes, there can be different things on disk speed and bandwidth performance. So
Okay. And second question slash comment, has Epic considered maintaining a canned persona mesh configuration that would jumpstart a campus's ability to test internally for the things on your top 10 problem list? We'll be able to test the number one problem, the MTU, when 5.0 is released. And we have talked to Mark about that one. But any comments on that?
Yeah, I mean, I'd like that as a personal goal I have this year, is just really just to try to have like a checklist of things to go through that you go when you're setting up your Science DMZ or a DTN, a series of tests or something, you go out through there and have these things enumerated. I mean, hopefully we can get some sort of script and automate it, but we'll see. But if we can just have like, the old Staples easy button. You hit this thing and it runs a series of tests and it spits out something like, oh, you got a problem here. Yeah, that's the utopian world. But we're trying to get a series of tests like that going this year, possibly for supercomputing, but related to our DTNs and tests that'll combine both perfSONAR tests, network tests, as well as some data transfer and some system benchmarking tools as well. So it's a whole series of things we're trying to get done. We're just trying to, build it in Lego blocks, and hopefully we can build something cool at the end and have some fun with it. But
Okay. So those were the questions right now. I'll put out a last call if anybody has anything that they'd like to ask Ken. And we'll make sure that all of these links end up in the mail that we send out, along with a link to that previous talk that he's been mentioning. It should just be in the channel where all the other talks are.
yeah, it's in the slides.
Okay. And we'll make sure that we get this video and those slides posted as well. So we will have one more talk next week. Michael Sinatra from ESnet is going to be talking a little bit about some cyber infrastructure and information security topics, and we'll get the abstract for that posted next week. And then after that, we have another gap where we don't have talks, so we'll probably be putting a pause until we hit the fall time frame. So thanks to Ken for this great talk, and we'll make sure that we get it posted, and we'll see everybody next week. Thanks all.
Thanks all.